The work now underway on board the International Space Station is designed to support deep space exploration in the future and provide benefits on Earth today. The Expedition 33 crew members are working on experiments in astrophysics and Earth science, in education and in technology development, and in human physiology and performance.
There's a myriad of things that are going on, not only U.S., but European, Japanese experiments. There's experiments from all over the world that we'll be doing and hoping help some of the human research that's going on.
A top priority is learning how a prolonged stay in space affects the human body. Some of the data is gathered from observing how crew members operate in microgravity. Some of the data is gathered in the form of biological samples from the crew that will be examined on the ground after the flight.
We will study the bone tissue pre-flight and post-flight. We'll perform blood tests. It's a large area for research.
At the same time, throughout the mission, the crew members spend time each day in practical application of the best theories about how to counteract the negative effects of living in space, trying to prove concepts that will keep deep space explorers of the future healthy on missions that will last for years. This work also contributes to the station crew members' overall health and physical fitness, so they're better able to work with all the other experiments on board, including some that have a similar goal, such as a study of the Medaka fish.
The importance of these very small fishes are they have bones and muscles, just like human beings. So what we're trying to do is have them stay in space for a longer duration and then bring them down and then take a look at their bone structures and muscles and see the effect of microgravity.
The crew members tend to the operation of that experiment and other investigations going on in the station's several laboratories, serving as the on-orbit hands for Earthbound researchers working in a number of scientific disciplines.
And those kinds of equipments will be acting as lab assistants. All kinds of media that have to be mixed, and temperature has to be maintained. Certain timestamps will have to be kept, and everything needs to be done with a lot of precision and a lot of attention to detail.
This platform in space supports all of that research, plus a whole slew of experiments on the outside of the space station that are constantly gathering data without the assistance of the human crew members. For example,
we have the GEM exposed facility that has some even NASA payloads outside. For example, MAXI, an X-ray, an all-sky X-ray detector on the outside. We're getting ready to take up scan test bed on HTV, which will go on like an external logistics platform out there, and of course alpha magnetic spectrometer sitting out on the starboard side as well.
Taking advantage of being in space to gather information on cosmic particles for researchers who are trying to learn what the universe is made of and how it began. For all of the crew members, there is one other wide-ranging, high-priority task that must be completed so that these dozens of scientific investigations can proceed.
And the task is to maintain the space station in due condition so that all the units and all the apparatus perform as they should. And should any of those break down, to be able to fix it.
That means performing regular maintenance work, being ready to repair hardware that breaks down, and possibly doing a spacewalk if needed to tend to the equipment on the station's exterior, although no spacewalks are in the plan for this increment. There will be a good bit of traffic at the space station late this year. Along with the goings and comings of 3 uncrewed Russian cargo ships, Williams, Malenchenko, and Hoshide depart the station in their Soyuz spacecraft in mid-November to conclude Expedition 33. Ford becomes commander for Expedition 34, and in early December, he and Novitsky and Tarelkin welcome a Soyuz carrying 3 experienced space flyers, station veteran Roman Romanenko of Roscosmos, and first-time station crew members NASA astronaut Tom Marshburn and Canadian Space Agency astronaut Chris Hadfield. They will all be on hand to support the planned arrivals of 2 American commercial cargo ships, SpaceX's Dragon and Orbital Science Corporation's Cygnus, which are expanding the station's fleet of delivery vehicles.
They fly up underneath the space station just within reach of our Canadarm2 robotic arm. We'll fly over top of a pin and grapple that vehicle and berth it to the bottom port on Node 2, right under the U.S. segment, and have access to the cargo.
Those cargoes, tons of food, fuel, oxygen and air, clothing, work supplies, and science hardware, are vital to maintaining the expedition crew members themselves and completing the mission of the International Space Station, to prepare human explorers and their tools for the deep space exploration missions that are moving off the drawing boards right now.
The ability of the humans to not only function in space, but be very functional when they arrive at their destination. Those are the kinds of things we're learning from the science. Fuel technologies, fuel transfer technologies, and all the things we can learn about the space environment are all valuable to us for pressing on out.